Hi, this is Paul. We're doing Leetcode must-know interview questions, and today's challenge is invert binary tree. This is labeled as an easy challenge. Given the root of a binary tree, invert the tree and return its root. What does that mean? Well, let's look at example 1. Example 1, the root node is 4. It has two subtrees. It has a left subtree, it has a right subtree. We want to invert that so that the right subtree becomes the left subtree and the left subtree becomes the right subtree. But also notice that the subtrees are inverted. That, for example, the left subtree, which starts out as 2, 1, 3, becomes 2, 3, 1. So as always, when we're dealing with trees, trees are a recursive structure. You know, every node in the tree is also the root of a tree. Even the leaf nodes are, could be considered the root of a tree that doesn't have any subtrees. So we can just swap the left subtree and the right subtree. Before we do that, we want to invert those trees, which we can do with recursive calls. So let's look at how we would do that. I'm going to move this over. Okay, actually, let's look at one thing here. I just want to double check the constraints. The number of nodes is in the range 0 to 100. The 100 we don't care about. We care about the 0 because we want to know whether or not it's possible for the root input to be null, which it is. So let's handle that first. That is an edge case. So let's say if root equals null, return null. I suppose you could say return root as well if you want to do that. All right, the nodes. Let's reverse. Okay, these are called tree nodes. Let's reverse the, let me get the names right, val, left, and right. Well, the val doesn't matter. Tree node left equals invert tree root dot, yeah, that's right, root dot left. I'm going to copy that. We'll say tree node right equals invert tree root dot right. So that gives us inverted versions of the left subtree and the right subtree. I think this is easier than, another way to do it would be to do the swap first, to put one of the subtree pointers in a temp variable, and then do the swap, and as part of the swap, do the invert. But I don't know. This way makes more sense to me. We'll just invert the trees first, and then we can just do the swap without a temp variable. We'll say root dot left equals left. No, I'm sorry, we call it left. Root dot left equals, jeez. When you tell yourself that something is easy, you have a much better chance of messing it up because you're not careful with it. All right, root left equals right, root right equals left. and return the root. All right, let's try it. All right, the basic test cases pass. Let's submit this. And it's the same thing we got yesterday. There's not enough accepted submissions to show data. I mean, that's surprising to me because these are just like, I don't know. It's, they're binary trees, which is something that you should know about. Maybe people consider these to be just like too easy to do them. They skip the easy ones and go straight to medium and hard. But okay. Again, it's a recursive solution when you get a problem involving trees. First thought should be, is there a recursive solution to this? Often there is, not always. But yeah, that's it for Invert Tree. Hope you enjoyed it. Feel free to like, like, subscribe, comment, and see you next time.